So you've seen how Solid Edge with Synchronous technology allows us rapidly create initial designs. That's the beauty of direct modeling. But what about finalizing that design with precision parametric work? Synchronous technology gives you the best of both worlds: fast direct modeling and precise control. Here we'll take our spring clip concept and ensure it fits and ready it for its detailed drawing. Let's take a look at how this will work inside Solid Edge. Here we can assemble this clip to our base part simply by selecting a few faces. Simple drag and drop, and Solid Edge knows what to do next. Definitely a time saver when working with hundreds of components. I have this in roughly where it needs to be. I can come back and get this exact when I start seeing the bigger picture. Here we need to assemble this USB block so we can tell just how much change we need to make to the clip. Notice all the nice visual feedback Solid Edge is giving me when selecting faces and axis of cylinders. The first precise change we need to make is to close up this gap between the top of the USB block and the underside face of the clip. In most other CAD systems, you'd have to make this change in the 2D sketch level with sketch relations. In Solid Edge, this isn't the case. We can relate faces in 3D instead. Here we'll add a coplanar relationship to close the gap. Easy, and know it's just how we do it. Looking at the back, I notice the tabs on the top are not square to the top face of the part. No problem. A perpendicular relation will fix this small problem. Let's start detailing this model, and of course dimensions are key here. Solid Edge has two different ways to add dimensions. The first is like most other CAD systems, where you add sketch dimensions when creating the sketch. The second, however, is unlike other CAD systems and much more intuitive. Just add the dimensions directly to the model like you see here. A dimension can be locked to maintain that aspect of the design, or left floating so that we still have flexibility for further design changes. We'll lock this one down. The arrows allow us to control the direction of the change. What face or faces will move with that dimension. We'll add another dimension to our other tab and lock it down. Notice as we place this next dimension and change the value, the tab remains at the width we set it. We'll continue detailing our design with a few more dimensions. And it's not just linear dimensions. Let's detail an angle here. All of these dimensioning tools are fast, easy to use, and most importantly precise. What's more, anyone can understand them when it comes to a review. At this point, we need to finish working on the other end of the clip. Another 3D relation will do the trick to move and match the angle of the bracket. This tool that you see on the screen is called a steering wheel. With this, we can drag and drop these faces, accurately snapping them into place around the dimple. The final assembly relationship we need to lock the clip down is to line up the center of the slot to the center of the dimple. This spring clip needs to fit inside the groove of the USB block to hold it into place. Once again, a simple 3D relation between the faces allows them to line up precisely. To get the jog of the clip to line up, we could add the same type of relationship, or how about just a simple drag and snap using the steering wheel? One last subassembly to bring in is the inline fuse assembly. The tabs on the top of the clip will support the inline fuse, so we need to make sure it will fit tightly into place. Just like we saw earlier, putting parts together is easy in Solid Edge. Select the face, edge, or axis from one part and the same type selection on the other part, and they just go together. The side-to-side movement is not that important, so we can just drag it to a rough location. I know the wire diameter is less than 3 millimeters, so using the steering wheel we can create a 3 millimeter offset from the selected face before snapping it to the other tabbed face. This leaves us with a 3 millimeter gap, precisely how we want it. This area is too wide. A drag and snap to the end of the fuse will work. For dimensional control here, we can design to the inside or outside. It doesn't matter which one we change, Solid Edge will always take into consideration the material thickness. This outside dimension, I'll just take the default value. Now let's place a dimension to the inside. This dimension I know needs a value of 9 millimeters, and if you notice, the outside dimension has updated to the thickness difference. Or I really want the outside dimension to be 10 millimeters, so we can change it and let the inside reflect the thickness value. The 10 millimeters is an important part of my design intent, so we will lock that dimension. Let's start creating a drawing ready for manufacture. First of all, let's create a custom view of the assembly so that all aspects of the part can be seen. And let's have that shaded. Now let's place a few views of just the clip. So remember the 3D dimensions we added at the part? Watch how fast I can bring those into this view. What we've seen here is how Solid Edge with Synchronous technology gives you the best of both worlds. Fast, direct modeling and precise parametric control. Relating faces together, dimensioning with design intent control, and drag and snap editing. All in 3D. No sketch work in sight. Fast and easy, but most importantly, accurate.